Here's a real-world counting problem. A meal delivery van visits an apartment building with units numbered 1 through 199. The van stops at every apartment whose number is a multiple of 11, because a senior lives there. It also stops at every apartment whose number is a multiple of 13, because a newcomer family lives there. And if an apartment is a multiple of both 11 and 13, the van still visits it just once. We count it once. The question: what is the sum of all the apartment numbers where the van stops? Before I show you anything, pause and try it yourself. Here's a hint. There are over 30 stops, so don't add them one by one. Look for the structure. Pause now. I'll wait. Let's start with just the multiples of 11. They are 11, 22, 33, and so on. How many of them are there below 200? And what's the largest? Then use a smart sum trick rather than adding everything by hand. The multiples are 11, 22, 33, all the way up to 198, which is 11 times 18. So there are 18 terms. Now here's the trick. An arithmetic series sums to n times the first plus the last divided by 2. That's Gauss's pairing idea. First plus last gives a constant pair sum, and we have n over 2 pairs. So the sum is 18 times 209 divided by 2, which is 9 times 209, equals 1881. Now do exactly the same thing for the multiples of 13. How many are below 200, and what's their sum? The multiples of 13 go 13, 26, and so on, up to 195, which is 13 times 15, so 15 terms. The sum is 15 times 13 plus 195 all over 2. That's 15 times 104, equals 1560. If we just added those two sums, 1881 plus 1560, we'd get 3441. But that answer is wrong. Which apartments did we count twice, and what's their total? Apartments counted twice are the ones that are multiples of both 11 and 13. Since 11 and 13 share no common factor, the smallest such number is 11 times 13, which is 143. Below 200, there's just that one apartment, number 143, so the double-counted sum is 143. Each of those overlap apartments should appear in the total just once, but we added them in twice, once with the 11s and once with the 13s. So we need to subtract the overlap one time to fix it. The formula has a name. Can you write it down? This is called the inclusion-exclusion principle. The sum of the union of two sets equals the sum of one, plus the sum of the other, minus the sum of their intersection. Plug in 1881 plus 1560 minus 143. That gives 3298. That's our answer. And here's the lesson worth keeping. We chain two beautiful tools. The first is Gauss's pairing trick, which turns a long arithmetic sum into a one-line formula. N times the first plus the last divided by 2. The second is inclusion. Exclusion. When two patterns overlap, add both totals and then subtract the overlap once, so nothing is counted twice. Together, these two ideas turned 30-something terms into 3 short multiplications: learn, compete, and win at competitivekids.org.